Swayam Prabha. Digital India. Educated India.
So let's continue with the isometric views. So last time we did some math, okay? So what we had was a unit cube, and let me take a block in my hand. What we had was a unit cube, okay? So this was the x-axis of this was the y-axis pointing towards me, z-axis, okay? And what we did was we rotated this unit cube about the z-axis by an angle alpha, and then we rotated this cube about this horizontal axis by an angle beta, right? So when we did transformations, we rotated the object of the unit cube about the z-axis, then about the x-axis, and then we performed the projection on the vertical plane, that's the screen plane, okay? When we did the transformations, we pre-multiplied the rotation matrix about the x-axis with RZ, and then we pre-multiplied the projection matrix, and we got the new coordinates or the projected coordinates of the points P, Q, and R. Okay, so this is point P, Q, which is pointing inside the screen, and R over here. Okay, we computed the lengths OP, OQ, and OR. Okay, we equated them. OP equals OQ, O equals OR. We did some algebra, and we eventually got our solution: beta to be equal to plus minus 35.26 degrees, and alpha to be equal to plus minus 45 degrees. Okay. So if we plug in, let's say the positive values, alpha equals 45 and beta equals 35 degrees, 35.26 degrees over here in our transformation matrix, we get G equals 1 over root 2, 0, 1 over root 6, minus 1 over root 2, 0, 1 over root 6, and 0, 0, root 2 over root 3. And last time we figured that the foreshortening, the unit lengths OP, OQ pointing inside, and OR, they all got foreshortened by a factor root 2 over root 3. Okay? Right? So this is the x coordinate of point P on the projected xz plane, your screen plane. The z coordinate, okay, likewise the x coordinate of point Q, the z coordinate, x coordinate of point R, and z coordinate. Okay. So we figured that OP, okay, OP would lie along the x axis, which is at 30 degrees to the horizontal. Likewise, OQ, which is pointing inside, would lie along OY, which is at 30 degrees from the horizontal again on the other side. And OR, which is vertical, will remain vertical here. Okay? Let's say this is the unit cube. Okay? 45 degrees, 35.26 degrees. Okay? All right? How will the bottom plane of this cube show up? How will the bottom plane of this cube show up? Like so? Yeah? How would this plane show up in the figure? Like so? Right? And how would this plane show up? Okay, parallel to this plane. Okay. Now, once you identify the OX, OY, and OZ axes of the object, it's fairly straightforward for you to identify a point if I give you the coordinates. For example, if I give you the coordinates of any point as 30, 40, and 50, okay, 30 for the x coordinate, 40 for the y coordinate, and 50 for the z coordinate, how will you locate that point on the plane? What you would do is you would go 30 from the origin parallel to the x-axis, right? Let's say you've gone here, okay? And then you would go 40 parallel to the y-axis, over here maybe, right? You're still on the xy plane, okay? And then to plot 50, you will stand here and go vertically upward, okay? All right? That's how you would locate your x, y, z coordinates as 30, 40, and 50 respectively. With me? With me? Not yet. Good. Yeah?
Why did we divide it by root 2 by root 3? We should take that only root 2 by root 3 is the rule. If we have to go 30 on x, we should go root 2 by root 3 is 30 on x.
So Avikalp says, why go 30 along this, 40 along this, and 50 along this? Why are we not using this foreshortening factor? And he's absolutely right. Okay? And at this point, I would like to differentiate between something called the isometric drawing and isometric view. In an isometric drawing, you would be using that foreshortening factor. In an isometric view, it's okay for you to use true length. The object just gets scaled by root 3 over root 2, that's all. Okay? The other way around. All right, so last time we were doing this example. Let's redo this again. At this time, let me say that this is the length direction of my object. So stay with me here, okay? Let me say that this is the length direction of my object. Let me say that this is the height direction of my object. And if I go to the top view, this would be what? The width. Once I identify my length, height, and width directions, it's much easier for me to draw the isometric drawing or isometric view. Okay? Let's do that. What did I say this was? Length. How about this? How about that? Width. Good. Okay, I'm drawing x, y, and z the other way around now. This is my x direction, okay, which is still at 30 degrees to the horizontal. My y direction, which is still at 30 degrees to the horizontal, and z direction is vertical. Okay? Now, I'm keeping my length direction along the x-axis. Stay with me here. I'm keeping my length direction along the x-axis. Okay, that would mean that all features along this direction are to be drawn along this direction in the isometric drawing of view. I'm keeping my width direction along the y-axis. All features from here to here along that direction are to be drawn here. And z I'm keeping for the height. Okay? So if you look at this object, you would see that this is a Fevicol joint. So if you look at this object, it's composed of two features. Okay? This one is a block, a slanted block, and this one is like a tapered rib. Okay? So let me draw the bounding box for the slanted box. Origin? Yeah? This is the origin? What is this length? 40. Wonderful. What is this? Great. What is this? Huh? Wonderful. What are the coordinates of this point? 20, 40, 30? Great. Not very difficult. That is precisely how you need to draw isometric drawing or isometric view. Okay? The bounding box for the slanted or sliced box ready. Now let me draw the bounding box for the tapered rib. Okay? From here to here, the length is 60. So I'll go from here to here, 60, and then from here to here, 15, 15, 15. Okay. So I'll go 60 from this point along this direction, along the x direction, and cell phones off, please. And I'll go 15 from here till here, and then I'll draw a line parallel to the y. Okay? Now let's focus on this part here. Let's focus on this. So this face of the rib is coinciding with this plane. Okay? What is this length? 10? 10? What is this distance? 15? This distance is also 15. Okay? Right? I join these 2 points. Likewise, I have another square here, and I join these 4 vertices to get a block within which the tapered rib is going to be. Okay? Okay? Now notice that I'm only using the construction lines. I haven't yet begun to draw the actual solid. Right? Okay. There is a reason for that, and I'll tell that reason to you in a little while. Would this edge be visible? I don't need to draw this. Would this edge be visible? No, I don't need to draw this either. How about this? Right? My rib is ready. You draw the isometric drawing or the isometric view the way you see it. No hidden lines. Okay? Absolutely no hidden lines. Right? How about the sliced block behind the back or at the back of the rib? Do you see this edge? Yes. Do you see this one? Yes. You do? Yes. So you would see that edge only partially, not completely. Yeah? Yes. Okay, and since there is a slant, I get this. Okay, since there is a slant which is very similar to this, since this plane is the same, this line will have the same direction cosines as this line. Okay? Am I done? As simple as that. No rocket science. Okay? What do you say about this edge? Would you actually see this edge or no? Why do you say that? Discontinuity, because the planes are different. This plane is not the same as this plane. Okay? So you would see this line. So a lot of people came to me last time and asked me, well, sir, why only this orientation? Okay? Why can I not have the object placed differently? Sure, you can. So instead of showing the object like this, you can turn it around about the z-axis by 90 degrees and have this rib show along the y instead of along the z. Perfectly fine. Or you can turn it around by 180 degrees and show the rib going the other way around along the z, along the x. Okay? So there are multiple possibilities in which you can show the isometric drawing or view. Word of caution: no hidden lines are to be shown like we do in case of orthographic views. No hidden lines are to be shown. Okay? We stay as realistic as possible when we show the isometric drawing or view. Okay? So when you're drawing isometric views, you need to be very, very careful. Okay? You draw a solid line only when you're absolutely sure that you will see that line. Otherwise, you don't. Okay? Otherwise, you will end up using your eraser and wasting time and spoiling the sheet. Isometric views are realistic. We show what we see. Okay? Unlike in case of orthographic views, where we show even those features that we don't see by means of hidden lines. Okay? Yeah? Ignore that. Huh? No. That scale is different. That scale is, so maybe what I did was I scaled this 60 to 40. Maybe that's what I did. So at this time, ignore that. Okay. So you draw an isometric view with the help of orthographic views, right? But you don't have to strictly adhere to which is the left view, which is the right view, which is the front view, which is the top view. Those three views are to give you an idea of how the object is going to look like. Once you get the idea, you can choose the orientation of the object the way you want to show as many features as possible in solid lines. For example, had I shown this feature, tapered rib, at the back, would it have been a good idea? No, because then a major part of that rib would have been occult. Okay, major or possibly all, I don't know. Okay, would it have been a good idea for me to rotate this by 180 degrees and maybe not see this slant on the plane? No? Yeah, so you need to orient the object in such a way that you get to see maximum features. Okay?
So when we are drawing this isometric drawing, then we have to take the real values of the foreshortened.
Isometric drawing, foreshortened. Isometric view or isometric sketch, true values. All right. Something very important. So remember in the first class or the second class, and definitely in the first lab, you did a lot of exercises on ellipses. We are going to be drawing a lot of elliptical arcs or ellipses in isometric views. Okay? You see that unit cube on bottom left? Okay? Imagine that you have a circular feature. Imagine that you have a circular feature here. Okay? You have rotated this object twice and projected it on a vertical plane. Okay? Now let me turn this object around. You will have a circular feature here. How would that circle look? Are you sure? Are you sure? Absolutely? Positively? Definitely? Okay. I thought just in case you weren't sure, I would back myself up with a little bit of math. So this was the projection matrix. Okay, alpha equals 45, beta equals 35 minus 35.26. Okay, if you have a circle on the xy plane, okay, which is the xy plane, which is the bottom plane of the cube. Okay. The coordinates of a point on the circle will be a plus r cosine theta, b plus r sine theta, and 0. A and b are the centers of the circle. The central coordinates of the circle are the radius. Plug in these values over here, multiply this thing by this matrix, get the new coordinates. Okay, do some algebra, eliminate theta. Okay, and then compare it with your generic equation for a conic. Get what A is, what H is, what B is. Okay, and the test is, the litmus test is for an ellipse is less than. Okay, interesting, right? You choose any value of A, any value of B, any value of R, h squared minus AB will always be minus 12 in case the circle is on the bottom plane. Okay, so a circle gets converted into an ellipse, right? Okay, same thing, the circle is on the YZ plane, the X direction, the Y direction, the Z direction. The circle is here. Okay, ellipse, do the same exercise. Okay, if it's on the YZ plane, your Y coordinate will be non-zero, your Z coordinate will be non-zero. Do the same exercise. Okay, and you'll find that your litmus test holds. In this case, h squared minus ab is equal to minus 3, which is smaller than 0. Okay, and the same thing if the circle is on the xz plane. Okay, same thing. The interesting part is, irrespective of what A is, what B is, what R is, these values remain constant. H squared minus AB, it remains constant. Okay, let's get to a tougher problem. Shown on the screen is the third angle projection of an object. I'll spare you the effort. I'll tell you that the object looks like this. 10 seconds to clear your throats. Now, if you realize, you can actually break this object into 3 parts. Okay, the part on the back, which is a resting feature. Okay, a part on the right. Okay, so this is the first part, this is the second part, and this part would be the third part. Okay, you can break this object up into 3 parts. Okay, divide and rule, that helps. You can have a bounding box corresponding to the part which is resting at the back, and you can have one for this one, and you can have another bounding box for this guy here. Okay? Okay? Now, for us to understand, let me explicitly mention the x, y, and z axes. Okay? Now, let the x direction have all the features along this direction. Let the height direction have all the features along this direction. And let the length be drawn along the y axis. Okay? Okay? Let's get started. Let's first draw the bounding box corresponding to this guy here. What's this height? 70. What is this? 60. What is this? 10. Once you have identified the 3 dimensions of a box or of a block, you can draw parallel lines along the x, y and z and go ahead and draw the block. Okay. So I'm drawing a block that would encompass this feature here. What is this length? 50. Right? So 60 minus 10. Okay. What is this height? 40. The same dimension, got one face. If I got one face, all I need to do is draw lines parallel to the y and get this block. How about the third one? This length is the same as this length. Okay. Now what is this length here from the origin? What is this length? 70. I'm looking at all this length from here till here. 40 and what's the radius of this? 25. So 25 plus 40 is 65. Okay. So this would be at 65 from here maybe. Okay. Is it going to be difficult for you to get this block? Is it going to be difficult for you to get this block? No? Fairly straightforward? Okay? All right. Now let's try to get this slant here. This slant here. Okay? And that would happen, or that would appear on this face. Okay? The corresponding slant will appear on a face parallel to this on the other side. Right? Okay? Now focus your attention on this. This line is this line here. Likewise, this line is this line here. Okay? These vertical lines are this and this. Okay? Okay, and notice that there is a slot here. Okay, so I have taken away a piece of block from this. Okay, the width of the block is 40, the height of the block is 30. 30 and 10. Well, I said the block. Well, yeah, so if you want to call it a trapezium, yeah, trapezoid, yeah, but it's equivalent to taking a block of 40 by 10, 40 by 30 by whatever the distance is. Okay? Anyhow, so this is the critical aspect of the drawing. Identify this length or this height as 30. Okay, go from here parallel to this, identify this height. Okay, get this point and get this point. Likewise, go parallel to the y-axis, identify that vertical line, get that face. So this face would correspond to the face, correspond to this face here at the back. Okay. Okay, now start drawing. Now start drawing. Okay, I'm working with features on the slant surface. Okay, now I'm ready to start drawing solid lines. I'll see this. Will I see this? Will I see this? I would see this face. I will see this face here on the slant. This line. This line, this line, this line, this line. Okay. I've worked out the details on this slant here. Okay? I'll see this vertical line, I'll see this vertical line, this one, I'll see this face, I'll see this vertical line, I'll see this vertical line. Okay? How about the line here? I'll see a partial line corresponding to that, not a complete line. Okay, so do appreciate how judiciously I'm drawing my solid lines without spoiling my sheet. Okay, and that can happen only if I'm prepared. If I'm not prepared, I'll start making mistakes. Okay? Now, here comes the interesting part. This circular arc will be appearing as an elliptical arc on which plane? On this plane here. Yeah? On the xy plane, or on a plane parallel to the xy plane. Do you remember the 4-center method? You do? Yes? Okay. For that, I need to draw a rhombus. Okay, that would bound the circle or bound the ellipse. Right? The length of the rhombus is going to be what? The length of each edge of the rhombus is going to be what? 50. So this length is 50. I have one length. This is 50. This is 50. This is 50. I've got a rhombus on the top face of the block. Okay? Identify the longest diagonal. Okay? From this vertex, join the midpoint of this edge. From this vertex, join the midpoint of this edge. You have two centers. You have the third center here. You have the fourth center here. Okay, with this as center, this as radius, draw an arc. With this as center, this as radius, draw another arc. Okay, so since this is a circular arc, I don't need to draw the entire ellipse. I only need to draw half of the ellipse. Okay, the rest I can join using straight lines with the main part. Here comes the trick. What do you say what we are going to be seeing here? A parallel ellipse. Now,
We'll draw vertical line tangential to the ellipse, and we'll draw that till that vertical line.
okay, but you are a little ahead of me. Now, do you think that drawing a rhombus to draw that ellipse would be a good idea? No? No? Absolutely. So what do you do? And then you're going to be drawing only half the ellipse. You have the center for this one, which is here. Okay? And if you have to draw an arc which is parallel to this arc, what do you need to do? You need to go down by what distance? By 10. You need to go vertically down by 10. Okay? Identify the center here. The same radius from here to here. Okay? Draw this arc. Okay? If you start making a rhombus to draw this ellipse, you will be wasting time. That's a trick that you need to keep in your mind. Likewise, from this center, go down by 10. Go down by 10. Identify the center with this as radius. Okay? Draw an arc. Now, this arc is not going to be complete. This arc is going to be partial. This arc is going to be partial because there's this vertical line here. Okay? All right? And then join this guy. The rhombus that we use to make the ellipse. What do you mean? To get the ellipse here, this length is 50, this length is 50, this length is 50, this length is 50, this angle is 60, this angle is 60, this angle is 120 degrees, this angle is 120 degrees. You have all the conditions necessary for you to have an ellipse enclosed within a rhombus. Okay? What? Lens. You got the block, no? You have this block here, okay? And of course, what's your question again? If the diameter of a circle is 50, okay, what would be the length of the bounding square, of the square that is bounding the circle? 50? Okay, length and breadth would be the same. Same in case of rhombus. Absolutely. Same in case of rhombus. Okay, because what's happening is, if you are rotating an object about the x, about the z, and then projecting, your square is getting shaped into a rhombus. So far so good? So far so good? Okay.
While drawing the second arc at the bottom, where will you decide from where should I draw the vertical line?
It has to be tangent to the arc. So if you draw this arc using soft pencil, using construction lines, your arc will probably be here. It'll probably go somewhere like this. Okay? It'll go somewhere like this, and the point where the vertical line intersects with the arc, that is where you need to stop. I would need 10 more minutes. Be patient. So this vertical line is tangent to both these arcs. Yeah. Okay. Hold on. You can do precisely the same thing for this block here. Okay? What would be the length of the rhombus for this? Huh? 60? So this I know is 60. I can identify where 60 is from here. I can identify where 60 is from here. I can draw this line which is parallel to this line. I get another rhombus. Okay. I join, or I identify the longest diagonal. The same method, 4 center. I get 4 centers here. First 2 centers, the third center, the fourth center. Again, I need to draw only half an ellipse. Okay. With this point as center, this as radius, I draw this arc. With this point as center, this is radius, I draw another arc. Okay, and to draw the same thing at the back or on the back face, I need to essentially Control C, Control V. Control C is for copying, Control V is for pasting. Okay, but I cannot do that here. So what I would do is, this was my center for this arc. Okay, I would go 10 parallel to the x. Identify this as center with the same radius. I'll draw an arc at the back. Okay. From here, I'll go 10 again parallel to x. Okay. Here, I'll draw an incomplete arc and then try to figure out a line which is tangent to both the arcs. Okay. And then this vertical line is going all the way down. See this feature here. Okay. Please repeat. Are you with me? Do you think now it's going to be easy for you to draw the ellipse, or rather ellipses corresponding to this void, this circle? All you need to do is locate the bounding rhombus, same method, 4-center method, get the ellipse. Am I done? There would be one more elliptical arc, and that would give the impression or the perception of the depth of the void. For that, the same trick. I go 10 down with the 2 centers. What do you mean? For the second arc. It's a void, no? It's a cylindrical void along the z direction. Okay? I don't need a line. Okay, a few last things. Actually, I never needed this. This was only for our understanding and appreciation that I had marked the XYZ coordinates or the axes explicitly. We don't need this. We don't need this. In your actual drawing or in reality on your sheets, this is how the isometric, what did I draw? Drawing, sketch, or view? View. Isometric sketch or isometric view? Because I used the true scale, I did not use the isometric scale. That is even harder, and that's one of the reasons why we at times, somebody asked me, right? So that's one of the reasons why we prefer to use true scales at times. Okay? Thank you.